So continuing in skill 3, um, we're going to focus on two special case triangles. Um, so this Pythagorean theorem sort of gives us the ability, right, given sort of any two of the side lengths in a right triangle, we can find the third side. There are a handful of special triangles, right? So ones that have particular angle setups where we can actually go further and we can sort of take one side and use them to find the other two. So this works for a couple special triangles. So the first one we're going to look at is what we call 45, 45, 90. This would be a right triangle where obviously you have the 90-degree angle in the corner, right? Sort of our right angle. And the other two angles are evenly split at 45 and 45. This makes it an isosceles triangle, right? Two of the side lengths will then be the same. And so the ratio that you get, if you kind of leverage this, right, if you have these two matching angles, that means the sides across from them, what would be our sort of A and B sides, will have the same length. So they would be sort of x and x. And you can do a Pythagorean theorem, a sort of generic Pythagorean theorem. And what's going to happen is you'll find the hypotenuse here, the long side, across from the right angle is going to be x times the square root of 2. So whatever your value is for x, right, if it's 10, then your hypotenuse is 10 times root 2. If this is, right, 25, this would be 25 times root 2. If this is, 0.6, this would be 0.6 times root 2. The way I sort of like to write this out, right, so the book is sort of saying this is sort of a 1-to-1 to root 2 ratio. What I'll sometimes do here is think of this, right, so you're sort of A and B values are x and x, and then your C value, right, is this sort of x times root 2. So we can use this. So say, for instance, we're sort of given a triangle, right? We obviously need to know sort of some angle values, right? So 45 and 45, and then the right angle there. So the missing sides here would be sort of the A and B sides, so they're sort of x and x. We know the long side here, which is 14. So that means in our sort of ratio, in our setup, the 14 should sync up with x times the square root of 2. Those two values should sort of sync up, right? If my sort of initial side length x, my kind of reference side is this x value is my sort of A and B sides, the C side would be x times root 2. So what that sets up for me is I'm trying to sort of solve for x where I know that x times root 2 is 14. So the easy thing to do here is just do a quick division by the square root of 2, right? You're essentially trying to solve for the x because the x is going to sort of sync up with your missing side values. So if you divide everything by root 2, what's going to happen, right? 14 divided by root 2 is going to turn out to be about 9.9. In this case, we're sort of dealing with feet. So the length of the legs here, what would be my sort of A and B sides, would be 9.9. So I'm just sort of using this ratio, right? So x to x times root 2, subbing in the value that I know, in this case the 14, and then sort of solving for the other two. You can imagine there's this kind of one of two different ways this could go. Either we could be given the long side, which is our C value, and solve for the A and B values, or we could be given the A and B values and then solve for the long side. So in the homework, I'll sort of pick, if we look at something like number 13, in this case, we have another 45, 45, 90, and we're told that the short sides, what would be the sort of A and B sides, are both 12 inches, and we're going to solve for the C side, so that would be the long side, that would be our hypotenuse. So if we come over here, we can kind of see our solution. The idea, right, is you're saying, okay, so 45, 45, 90, right? So that syncs up with x by x times root 2. And the A and B sides, right, my sort of legs here are both 12. And then the side that I'm missing is the C value. So if x is 12, the C value is just x times root 2. So rather than in the other example when we were actually having to do a division by root 2, this time we're just multiplying. So 12 is x, so 12 times root 2. Root 2 is going to be about, right, 1.414. So times 12 gets us to 16.97. And that's going to be our that's going to be our final. You could round it to 17, I suppose. So using this sort of property, 45, 45, 90, using this property, we can sort of get a little bit more information from a little less information. And there we go.